Alright, we're Unit 4 Calculus, Day 28, Part 3. Find dy dx for each of the following implicitly defined equations. So now we're going to do the same thing we were just doing. So take the derivative of y squared. Again, that's the power rule, so we get 2y. But since it's y, we got to multiply that by dy dx. It's equal to the derivative of 2x is just 2. Now it would be dx over dx, but we're not going to write that because dx divided by dx is 1. And now derivative of 3y is 3, and then dy dx, because everything's in respect to x. So now our goal, just like what we did in Algebra 1, we want to get dy dx by itself. So we're going to subtract both sides by 3 dy dx. So we get 2y dy dx minus 3 dy dx equal to 2. Now I'm going to factor out the dy dx. What am I left with? I'm left with 2y minus 3 equal to 2. And now I'm going to solve this and get dy dx by itself. How do I do that? I do multiplication by division. So dy dx equals 2 all over 2y minus 3. Okay, and that's the derivative of that implicitly defined equation. Okay, let's try the next one. So let's take the derivative and just start right away. Derivative of 2x is 2. Derivative of ey is e to the y is e to the y times the derivative of the exponent is just 1, but then there's dy dx. Derivative of x squared is 2x. Derivative of y squared, or negative y squared, is negative 2y dy dx. So now what I want to do, I want to get the terms with the dy dx on the same side. I'm going to bring them over to the left, and then I want everything else over to the right side. So let's keep my e to the y and just times 1. We're just going to write it as dy dx. I'm going to add 2y dy dx to both sides, and then I'm going to subtract 2 from each side. Okay, now let's factor out dy dx. What am I left with? E to the y plus 2y, and that's equal to 2x minus 2. And now how do I get dy dx by itself? By undoing multiplication by dividing both sides by e to the y 2 plus 2y, so I get 2x minus 2 all divided by e to the y plus 2y. And again, once I know a point, which if that's a point of tangency of this function, I can substitute that in for x and y, and that'll tell me what the slope of the tangent line is, which is what the derivative is, and that's what we're doing here. All right, let's try these last two examples, and that'll be it for part 3. So now in this one, I want to take the derivative, but I got to treat it like product rule. So 2xy, we're going to do the derivative of the first. I'm going to treat 2x as the first. So derivative of 2x is just 2 times the second, plus leave the first the same, and then take the derivative of y, which will be 1. And then we got to do dy dx. And now let's do the other side. Derivative of 3y squared is 6y dy dx. And the derivative of 2x is just 2. Once again, our goal is to get all the dy dx's on one side, just like what we were doing in Algebra 1 when we had to get the a by itself or the x by itself. So I'm going to leave that there. We're going to bring everything over to the left. So minus 6y dy dx. Bring this 2y over. So we'll write the 2 first. 2 minus 2y. Now let's factor out dy dx. We're left with 2x minus 6y equals 2 minus 2y. And now undo multiplication by division. We're going to be able to factor some, I'll write it out the long way. First, we're going to be able to take a 2 out of everything, 2x minus 6y. So now let's factor out 2. I get 1 minus y all over x minus 3y Oops, sorry, I forgot the 2 there. And we can cancel out those 2's. And now, and let me work down here, dy dx equals 1 minus y all over x minus 3y. Okay, and so if I know the point, if it's a point of tangency, then I can find what the slope of that tangent line is by substituting in those values for x and y. Okay, and that's the derivative of that implicit equation. Okay, let's do the last one here, and that'll be it for part 2. Excuse me, part 3. Okay, so derivative of 5x cubed is 15x squared. Derivative of 3 is 0. Equals derivative of 2y is 2. And we have dy dx. And this is going to be a product rule, so I'm going to treat it like that. So derivative of 3x squared is going to be negative 6x. So derivative of the first times the second, plus leave the first the same, minus 3x squared, and derivative of y is 1, but then we got 1 dy dx, so I'm just going to write dy dx. Okay, now let's get all the dy dx's on one side. They're already on the right side, so I'm going to move the 6xy over to the left side. So I have 15x squared. I'm going to add 6xy to both sides. And this is going to be equal to what do we got here? So I got to take out a dy dx, and I'm going to have 2 minus 3x squared. Okay, if you had done it without a negative sign there, if you treated it, and I probably should have blocked that like that, negative 3x squared. You might need one more step in there if you didn't include that negative like I did. So now how do we get dy dx by itself? You have to divide both sides. So dy dx equals, and it's going to be 15x squared plus 6xy all over 2 minus 3x squared. And there's no common factors in the numerator that will cancel out with common factors in the denominator. So our derivative of this implicit defined equation is 15x squared plus 6xy all over 2 minus 3x squared. Okay? That's it for day 28 notes, part 3.